Good morning to all. Subject Electrical Machine Design EMG. Topic Design of commutator and brushes. Good morning to all. Electrical Machine Design. Design of commutator and brushes. Step 1. Number of commutator segments is equal to number of armature coils. Second point. Diameter of commutator. Pitch of commutator segment should be equal to bracket of pi d c divided by number of commutator segments whole bracket. The pitch should lie between 4 and 10 millimeter. 4 millimeter less than pitch less than 10 millimeter. Diameter of commutator. Second point. Peripheral speed of commutator should be less than 20 meter per second. Electrical machine design. Design of commutator and brushes continuations. Third step. Diameter of commutator. Third step. Distance between the brush spindles is equal to pi dc divided by number of poles less than 30 centimeter. Vc is equal to pi dc n divided by 60 less than 20 meter per second. Distance between the brush spindles pi dc divided by number of poles less than 30 centimeter. Dc is equal to bracket of 0.75 to 0.8 bracket capital D for small size machines. DC is equal to 0.65 to 0.7 bracket capital D for medium and large size machine. Continuation of design of commutator and brushes. Third step. In third step, first point, number of segments covered by brush should be 3 to 4. Third step, second point, maximum brush thickness for large and medium machine is equal to 3 times the pitch of commutator segments. Bracket for large and medium machine is maximum brush thickness for large and medium machines is equal to 4 times the pitch of commutator segments. That is for small machines. Maximum brush thickness for small machine is equal to 4 times the pitch of commutator segments. Third step, third point, brush width is equal to 12.5 to 16 millimeter small. WB is equal to area divided by thickness. 20 to 25 millimeter for medium. 30 to 40 millimeter for large machine. Design of commutator and brushes. Continuation. Fourth step. Number of brushes divided by spindle. First point. Calculate current through the brush from IB dash is equal to armature current divided by pair of poles. IB dash is equal to IA divided by P divided by SR. That is IB dash is equal to 2IA divided by P. IB dash is equal to 2IA divided by P. That is formula. Design of commutator and brushes. Topic. Fourth tips, number of brushes and spindle. Second point, current per brush does not exceed 17 ampere. Third point, number of brushes per spindle. NB is equal to current per brush arm divided by 70. Number of brushes per spindle, that is. Design of commutator and brushes. Topic. Fourth steps, number of brushes per spindle. In fourth point, contact area per brush is equal to AB. AB is equal to current per brush is divided by current density IB dash divided by NB. Fourth point, B point, calculate the number of brushes divided by spindle so that each brush does not carry more than 70 ampere current. In fourth point, number of brushes per spindle. Fifth point is brush thickness is equal to 3 into pitch of commutator. Design of commutator and brushes. Continuation. Fourth step, number of brushes per spindle. Sixth point is brush width is equal to WB is equal to AB divided by thickness of brush. Design of commutator and brushes. Fifth step, length of commutator is A. Assume thickness of brush box to be 6 to 8 millimeter. B. Calculate axis length occupied by brush boxes LB dash. Design of commutator and brushes. Topic. Fifth step, length of commutator. LB dash is equal to NB, width plus thickness, width WB, thickness TB. LB dash is equal to capital NB, bracket of WB plus TB. NB is number of brushes for brush box. Design of commutator and brushes. Fifth point, length of commutator In fifth step, third point, length of commutator LC is equal to LB dash plus end clearance bracket 2 to 4 centimeter plus allowance for stacking of brushes bracket 3 to 4 centimeter. Current per brush is equal to IB dash divided by NB. Topic, design of commutator and brushes. Performance of commutator. First, total losses. Second, temperature rise. Total commutator losses is equal to total brush friction loss plus total contact loss. BFL is equal to mu into AB double dash into P dash into VC, where mu is equal to coefficient of friction between brush and commutator is equal to 0.12 for soft graphite brush. Performance of commutator 0.15 for hot graphite brush, 0.2 to 0.3 for carbon brush. AB double dash is equal to total contact area of all brushes. AB double dash is equal to area per brush into number of brush per spindle, or AB into NB into number of brush arm. AB double dash is equal to AB into NB into number of brush arm. That is formula. Brush pressure on the commutator. Assume lap winding number of poles is equal to number of spindle. P dash is equal to 10,000 to 50,000 Newton per meter square. Performance of commutator. Brush contact loss is equal to bracket of voltage drop divided by brush set small bracket. Assume bracket 1.5 to 2 volts bracket into current per brush is equal to armature current small bracket and whole bracket. Kindly say notes. Performance of commutator. Second point, temperature rise. Theta is equal to 120 into loss in watts per centimeter square divided by 1 plus 0.1 Vc. Capital Vc is equal to peripheral speed. P dash is equal to brush pressure. Theta is equal to 120 into loss in watts per centimeter square divided by 1 plus 0.1 Vc. Again we say brush contact loss is equal to voltage drop divided by brush set into current per brush. In this formula, voltage drop per brush set, assume 1.5 to 2 volts. In this formula, current per brush, assume that is equal to armature current. Electrical machine design, EMD. Topic, design of interpoles. First step, interpoles placed midway between main poles to achieve sparkless commutation. Second step, MMF produced by interpoles has to neutralize the cross-magnetizing armature MMF. Third, moreover, an EMF has to be induced. Moreover, an EMF has to be induced. Design of interpoles. Third point, moreover, an EMF has to be induced to oppose the reactance voltage of the short-circuited coil undergoing commutation. Capital EC is equal to 2 BCP LCP VA, where BCP is a flux density under interpole at the air gap. LCP is axial length of the decreased interpole. LCP is axial length of the interpole, not decrease. Design of interpoles. The interpole or commutating pole MMF must be greater than the armature MMF, otherwise sparking will occur. The interpoles are connected in series with the armature winding. Dimensions of interpole. First, width of interpole is equal to WIP is equal to 1.5 towers. Towers is slot pitch. Towers formula is pi divided by P. Dimensions of interpole. Second point, actual length of interpole LIP is equal to bracket of 0.5 to 0.75 bracket L, bracket LIP or LCP. Third point, LGIP is air gap length under the interpole, that is bracket of 1.5 to 1.75 bracket LG. LG is length of the air gap under main pole. Fourth, height of interpole. HIP is equal to DYI minus D divided by 2 minus LYI P, where DYI is the inner diameter of the yoke. Design of interpole winding. Calculate the MMF required for interpole. ATIP is equal to ATA plus 0.796 BIP kg IP lg IP into 10 power 6. Again I said ATIP is equal to ATA plus 0.796 BIP kgip lgip into 10 power 6, where BIP is the flux density in air gap under the interpol, that is 0.3 to 0.5 Tesla. kgip is the air gap coefficient, that is bracket of 1.1 to 1.15 bracket. ATA formula is IA dash Z divided by 2P. IA dash is equal to IA divided by parallel paths. Dimensions of interpol, that is design of interpols. Topic: dimensions of interpol. Step 2, design of interpol winding. Step 2, find out the current in the interpol winding, that is armature current IA. Step 3, design of interpol winding. Step 3, calculate the number of turns in the winding. Capital TIP is equal to ATIP divided by IA. Design of interpol winding. Step 4, assume current density del IP is equal to bracket of 2 to 2.5 bracket ampere divided by millimeter square. Fifth step, calculate the cross-sectional area of the conductor of the interpol winding. AIP is equal to IA divided by del IP. Sixth step, calculate resistance of the winding. RIP is equal to rho LMIP TIP divided by AIP. Design of interpol winding. Step 7, find out the total copper losses in the interpol is equal to IA squared or IP. Eighth step, length of conductor is equal to bracket of L plus free length per conductor whole bracket. L is length. Good morning to all. Electrical machine design. Topic: design of commutator brushes. Question: problem: obtain suitable dimension for the commutator and brushes of 1000 kilowatts 500 volts DC generator having the following data: outside diameter of armature 170 cm, number of poles 12, number of armature coils 540, RPM 500. Solution: number of commutator segment is equal to number of armature coils, that is 540. Second solution: DC is equal to 0.7 D. 0.7 into 170 is equal to 119 centimeter. Third solution: check for DC. First, pitch tau C is equal to pi DC divided by number of commutator segment, that is pi into 119 divided by 540.